Hello students. Today I'm going to open the chemistry lab for you. Yes, let's learn the laboratory preparation of hydrogen chloride gas. Excited? So am I. But let's understand the equipments first that we are going to use. Here we go. The thistle funnel, delivery tube, and of course the gas jar. So let's assemble them in this manner. The other end of the delivery tube, as you can see, is then fitted in a washer bottle. This washer bottle contains concentrated sulfuric acid, which is going to act as a drying agent for our gas. And then the dried gas will come out from the other delivery tube and collected in the gas jar. So let's begin. In the flask, as you can see, we place some sodium chloride crystals, your normal common salt. And through the thistle funnel, you're going to pour concentrated sulfuric acid. Yes, it is concentrated always. But you can observe here, or a very important precaution, that this thistle funnel other end should be properly dipped. For that simple thing, you have to pour in more sulfuric acid. And the reaction definitely will start. Concentrated sulfuric acid will act on NaCl. But if we need the process to be faster, we need to provide heat. As soon as you provide heat, you can see a few gas bubbles here formed. That means the gas has formed, being colorless. It has gone via the delivery tube, entered here in the washer bottle. And then after it is being dried, it will then get collected in the gas jar. You can see the equation. Sodium chloride reacts with concentrated sulfuric acid and forms sodium bisulfate and HCl gas. Now, the temperature required here is less than 200 degrees. Now, you may wonder, why did I mention that the thistle funnel should be dipped? Students, you can imagine once the reaction begins, if the gas is formed, what will happen? The gas will escape out and you'll have no gas formed here. So that is what it is very important to have the thistle funnel dipped inside. Well, that was all about the preparation. Let's recap. Name the reactants: sodium chloride and concentrated sulfuric acid. Now, I'm sure many will feel that why do I need to have sodium chloride? Why not any other metal chloride? Yes, you can use other metal chlorides, but there is a reason that we are using sodium chloride, because it is cheaper. It's economical. Again, a question, why concentrated sulfuric acid? Why not any other like concentrated nitric acid? Well, nitric acid concentrated is volatile, means that itself will evaporate. So along with HCl, we will also get nitric acid coming out in the gaseous form. We won't be able to get HCl alone. Equation, yes, we learned just now. NaCl plus sulfuric acid less than 200 degrees. To write this is important. Name of the product is also important. Sodium bisulfate and hydrogen chloride gas, whereby the gas is shown by this upward arrow. Now you may wonder, what would happen if the temperature is above 200 degrees? Why less than 200? It's very simple. At that temperature, the glass apparatus that we are using will crack. And when we do not require more than 200 degrees, there will be a wastage of fuel. Not only that, let's see what happens if we raise the temperature above 200 degrees. We get a new product. Of course, we will get HCl gas, but we get another product by the name sodium sulfate. This sodium sulfate, which gets formed, forms a hard crust which sticks to the glass. And then for the next experiment, it's difficult to remove that and reuse the round bottom flask. That's the reason we need to write lower than or lesser than 200 degrees centigrade. Do you remember the drying agent? Yes, of course, concentrated sulfuric acid. Obviously, the question comes into your mind, can other drying agents be used? Absolutely not. The reason is the other drying agents will react with HCl. Now, can you name any other drying agents? Well, let me tell you, they are phosphorus pentoxide or quicklime, CaO, and this is P2O5. We will be using these drying agents in some other preparations. How is HCl gas collected? You saw in the picture, or you saw in the laboratory, I would say, that hydrogen chloride gas has displaced air. And how is the air displaced? It's upward displacement of air. Don't you remember that HCl gas is heavier than air? But why not collect it over water? If you remember this fountain experiment, yes, because HCl is highly soluble in water. If you collect it over water, it will dissolve in water and we will not be able to obtain the HCl gas. The final question of the day, neat labeled diagram of the laboratory preparation of HCl gas. If you need to draw this, lovely. Yes, I can see you have written concentrated sulfuric acid in this washer bottle. But hold on. Can you spot the mistake? I can see one more mistake. So be very careful here that they have to be dipped inside the liquid. Well, let's know more about this preparation, a few more details. How would I know that the jar is completely filled? We know HCl is a colorless gas. And how do I know it is being filled? It's come up to the brim. The gas is getting collected till the brim. How would I know this? Well, there is a very important thing to see that if this jar is full of HCl, we will start seeing when the HCl comes to the brim, it comes in exposure with the air outside. And soon you will see white fumes. Because HCl reacts with the water vapor in the air and forms hydrochloric acid. There's another way to understand whether this jar is full of HCl gas. You bring a rod, a glass rod, dipped in ammonium hydroxide. And once you bring it closer to the gas jar, you will again see white dense fumes. Can you guess? Yes, it gives dense white fumes of ammonium chloride. Like NH4OH plus HCl, ammonium hydroxide with HCl gives ammonium chloride, and water. So the dense white fumes is of ammonium chloride. What is aqueous solution of HCl gas known as? Aqueous solution means the water-based solution. Yes, hydrochloric acid. Now, how is HCl acid prepared? I'm sure you must be interested in knowing that. Is it prepared from HCl gas? Oh my God, too many questions. Let's handle this in the next session. Until then, thank you. Goodbye.